find the force of the bolt, we'll still use our conditions for static equilibrium. This time we'll use the fact that the sum of the forces in the x direction are 0, because it's not moving in the x direction. We'll use that the sum of the forces in the y direction are 0. So if we're going to do the sum of the forces in the x direction, we'll look at what forces do we have in the x direction. What we have is minus t times cosine theta plus the force of the bolt in the x will equal 0. So the force of the bolt in the x will equal t times cosine theta. You can put in the numbers. We just found our tension. It's 168 newtons. So we get 168 newtons times the cosine of 33.6 degrees. And that gives us a magnitude of the x component of the bolt force to be 140 newtons. So there's our x component. To find our y component, we'll do that the sum of the forces in the y direction have to be 0. And it has to be 0 because it's not moving in the y direction. So the sum of the forces in the y direction is mass times acceleration in the y equals 0. So we have t times sine theta minus mass of the sine times gravity over 2 minus mass of the sine times gravity over 2 minus mass of the post times gravity plus the force of the bolt in the y equals 0. So now we can solve for the force of the bolt in the y equals mass of the sine times gravity over 2 plus mass of the sine times gravity over 2 plus mass of the post times gravity minus t times sine theta. Put in the numbers that we know. So mass of the sine was 10 kilograms, so we get 10 kilograms times 9.81 meters per second squared over 2, and then there's 2 of those guys, so we'll just times that by 2, plus the mass of the post times gravity. Mass of the post was 5 kilograms times 9.81. Then we subtract t times sine theta. T is 168 times sine 33.6 degrees. Put all that through the calculator and we get the force of the bolt in the y direction is 54.0 newtons. Now to finish our answer, all we have to do is write our force of the bolt as a vector. So the force of the bolt is equal to the x component, 140 newtons in the x direction, plus the y component, 54 newtons in the y direction. You could also write it with magnitude and direction if you prefer, but since we have the components, it's just faster to do unit vector notation. So there's our tension and our bolt force.